Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, so today we're going to learn about Kubernetes architecture. So let's little bit of recap of last session what we did. In the last session we discussed about what is Kubernetes and why do we need it, what are the advantage, what are the benefits of having Kubernetes, and all related topics. But today we will work on today we will learn how Kubernetes works. Basically it's a Kubernetes architecture. So let's get started. So when we look at Kubernetes at a big picture, then we find it out is Kubernetes is an orchestrator for microservice apps. Now the question is, what is microservices? I think most of you must be knowing. If not, then just do some little bit of homework on that. But what I am saying here is Kubernetes can also is not only orchestrated for the containers which we discussed last session, but also it can orchestrate, it can manage a microservices. That's a capability what Kubernetes has. So that we call it Kubernetes is an orchestrator for the microservices app. Now, when I say orchestrator, that means yes, Kubernetes will manage your uh, microservices, service A, service B, service C, and then with the help of orchestrator, you can do the request to the services. Yes, you can send the request to the services and response you get it. So yes, that's things which is managed by Kubernetes. That's done by Kubernetes. Let's understand that is in a little bit of different perspective. Here, if you look at this on my screen, you have one football ground, soccer ground, and we have so many team members. You know that minimum players is required. I think 11 or 12, right? So we have so many team members. Now, if each one of these team members would play this game, and if they go to the ground, then what should be the objective of the each player? What do you think? What should be the objective of each player? So now, if you're thinking, okay, the objective for the soccer player is to make a goal, then it's wrong. It's wrong. Why? Because if each players, if they have a same goal, then they'll be somewhere near to the goal post, right? And you see this in the same image, all the players is around the goal post, they are trying to make a goal. So that way, you know that you cannot make any goal. You you will lose the game, right? So that's the thing. So what to do in this case, in this scenario? So then typically we bring a manager, we bring coach. Now coach has authority, manager has authority. He says, listen, do what I said. I know each one of you, I know each one of your capabilities also. You are good at something, you are not good at something. You have to do what I say, and if you do not follow my guidelines, if you do not follow me, I will throw you out of the this field. So now manager or coach or master, whatever you call it, they bring some discipline, and each of those player start working and playing together as a team, and each one of the player has certain responsibility. Now each of this player is not having objective of to make a goal, but just to pass the ball from one to another player. till we reach to the strike point where we have one or two player who will make a goal. So only one or two people out of the whole team has an objective to make a goal. Remaining people are just coordinating it. Okay, remember here each player has a certain qualities here, certain qualities, and all these players work together to make a goal. So now you must be wondering why we are discussing about it. Remember, I said Kubernetes is also an orchestrator for the for the microservices, also orchestrated for the microservices. So remember, in order to serve the request for the application which is based out on the microservices, the request has to pass through the many microservices to generate the right response for the end user. So here you can convert these each players as a microservices. Each of these players is a microservices, and each microservices has certain qualities, and each of these microservices need to work together in some coordinated manner to generate a response for the end user. And if these people are not working together in some direction, in one particular direction, then you will not be able to serve the response. But in the football ground, every player is been managed by coach and manager or master. But what about if you are running so many microservices in the Kubernetes cluster? Who will manage it? Kubernetes. So Kubernetes can manage your services, and Kubernetes will control over the all the anatomy of the microservices. Who should be talking to which one? Look at this here. Convert all these players into the services. Some of them are HTTP services, some of them are search services, authentication services, some of them are database log services, load balancer. So each of these are the services, right? Who's managing it? Kubernetes. Now, interesting thing here, you look at this here. There's a two HTTP services. Both is managed by, both is been load balanced by load balancer, and then remaining other services. You see that every microservices here talking to each other to generate a response. But someone has to manage all these microservices, so the behavior should be consistent, right? It should not be a different behavior. So someone should manage all these microservices. Someone should help you to orchestrate these microservices. That is where Kubernetes is coming. So yes, Kubernetes can help you to manage. Kubernetes will help you to orchestrate your microservices. Now if you look at this image, very interesting image, look at the only HTTPS. There were two HTTPS. The behavior of HTTPS service is same, you know that, but both are running on a different node actually. Look at this, node 1 and node 2, but still the behavior is same. There's no difference. Still that the HTTP is been load balanced by the load balancer, is irrespective of which node they are running with. So you see the load balancer service is running in the node 1, and HTTPS services, one of these is node 1 and another one is node 2, but still the behavior is same. How can it be possible? That is the magic of Kubernetes. So now probably you might not be able to correlate this discussion with the real-time stuff, but when we create a service, yes, I said when we create a service, okay, in Kubernetes, then you will understand how this Kubernetes orchestrate is a orchestrator for the Kubernetes. Sorry, how the Kubernetes is orchestrator for the microservices. When we create a service in microservices and that service will load balance multiple different services, then we'll understand that. But for time being, yes, this is a orchestrator for microservices. In fact, if you look at the Kubernetes architecture which we are discussing today anyways, you will find it out one of the best architecture for the microservices. Kubernetes product itself is a best microservices architecture which you can refer for any discussions or knowing the things. Okay, so with that, yes, Kubernetes is an orchestrator for the microservices app. Also, with that, we need to know how Kubernetes works. What is the architecture of Kubernetes? So typically, if you look at the high level, we have a Kubernetes cluster. We call it in short KX cluster. Okay, if you look at this here, this image very carefully, you have a k8s cluster. Inside a k8s cluster, you have a master node and the node. Now, when I say master, means master node, something like a coach. Remember, coach or manager or master, whatever you want to call it. Master and a node. This you have a 6 node in this. This you can consider as a player also. Okay, so in the Kubernetes cluster, you have master, you have a node. You have a multiple master for HA, high availability. You have a multiple nodes. And who controls the master? You see the some packages being sent to the master from outside and is been there. So now you have to elaborate all this stuff in a little bit detail. Okay, so master who's in charge, the real work is done by node. When I say real work, work means running the container, but here we run the container in the pod. Now what is a pod? I'll come back that to in the later section, but right now in the Kubernetes cluster, you have a master, you have a node, you have a multiple node, you may have a multiple master for HA, high availability. Master who's in charge for everything, and real work is done by node. Work means running a container. Where you run where you run the container? In the node. Same thing here I was discussing these services, right? Is can be running in any of these nodes. So node 1 and node 2, node 3, anywhere you can run it. Okay, as many you want it. So this is how it at a high level of Kubernetes architecture. Let's deep dive into this. See here. So now the package which we send from outside to the master, that's why we call it, typically we call it a deployment, though there's so many other names also, but I will not complicate right now. But if you look at it very carefully here, node has a pod. See here, node has a pod. Now what is a pod? Probably this is not the right time to discuss. Okay, what is a pod? We will discuss. We will spend one entire sessions on the pod. What is pod? But I see that inside a pod you have a container. That icon which you can see is of container. Okay, so from this diagram what you have understand is, in a cluster you have a master and a node. Both are node. Master also is a kind of VMs, virtual machines. Node is also kind of VM, virtual machines, but we call it a master node and then worker node. And in the each node you have a pod, and a pod has a container. That means in the Kubernetes we keep the container inside a pod. Now what is a pod? I don't know, but for at least I get to learn something here. Is like in the Kubernetes we keep the container inside a pod as per the image. So guys, so far so clear? So far so clear, guys?
Yeah. So can we say like one pod we can allocate for one container, or multiple containers we can host it in one pod?
So we will discuss on this. This is the pending
Okay,
topics.
fine.
Uh,
Okay,
we will discuss on. But for
got it.
time being, what we have understood, I wanted to know the architecture. Okay, fine. What we have? So we have a cluster. We have a cluster. Cluster has a master and the worker. Worker means node here. Okay, so master is also node. Node is also node. Okay, node is also node. Master node, worker node, and node has a pod. Pod has a container. And we have a deployment package which is coming from outside, sent to master, and master do the work. So master is in charge and node is doing the real work. So let's deep dive into that and let's understand more about the master. So what is the master? So guys, master typically in Kubernetes we call it the control plane. Okay, the Kubernetes control plane. You can call it a master also, you can call it the control plane also, it's up to you, whatever you want to call it. Okay, so now you see here master manages the node. Okay, so see here my master is in Linux and node is also in a Linux. Let me tell you here, this image need to be modified in this year 2020 2021. Node can be in Windows 2019 plus also. I repeat, Windows 2019 only plus. Okay, so yes, master has to be in a Linux. Kubernetes supports that only in a Linux, but a node can be, worker node can be Linux as well as a Windows. Okay, so that's the thing. So master manages the node. Master is in Linux. Node is also in Linux, but new 2019 plus it started getting supported. Okay, so guys, master has a four important component. Master node, the master server, which you can see when I start showing you the demo. Okay, master server will have a 4 important component. Now what are these component and what are the functions of this component? We will come to know in some time. See here, for the, because remember, for the any cluster, the master node is a very important. Why? Because the master node is the in charge of your cluster, something like your manager, something like your coach. Let's say if the coach is not there, you know that how these players will play without a direction. No one will control them. So we need some sort of control mechanism to control the integrity of the clusters. So who will manage those? Who will do this control stuff? Master node. Master node have a 4 important component, but it can be multiple master also. Why? Because if one, let's say one master node is there in your cluster and that suddenly have some health issues, CPU issues, RAM issue, hard disk issues, security issues, or some issues, it can be anything, right? So there must be some other master to take work on behalf of missing master, right? So it can be HA also. Typically you start, when you go for the production grade cluster setup, then typically you have a 3 masters. You can have a 5 or 7 as well. Okay, so this is the master can be HA also for high availability. So here if you look at this is a little bit interesting pictures. Look at this very carefully. Master is in Linux, node is in Linux, it can be in Windows 2019 plus also. Master has a 4 important component, I see that. But here if I see master manages the node, you see in this image you have a 4 node. But if I go inside a node, I see that node has a pod. Okay, node has a pod, node has a 1 pod, and node is, if you look at the right side, node has a 2 pod. Okay, so that means master manages the node and node may have a 1 pod or multiple pod. But if you go inside the pod, here you see left side, 1 pod you have a 2 containers. And here right side, if you look at it, each pod you have 1 container. So what I'm learning from this image? I'm learning something here is master node have 4 important component. Master node has to be in a Linux. Master node manages the worker, and worker node can be in Linux as well as in Windows. And worker node will have a pod, and pod have a container. Worker node will have a multiple pod, and each pod you may have a 1 or multiple container. Are you understanding it, guys? Are you understanding it?
Yeah.
Yeah.
Correct me
So
if I'm wrong. So worker node has more than 1 pod, and pod can be have more than 1 containers.
so we can say something like that. Worker node may have 1 pod or multiple pod, and each pod you may have 1 container or multiple container, depends on your requirement. Make sense?
Okay. Yeah. Thanks.
Yeah. Okay. So this is the things. So now let's do one thing. Let's focus on the master component, because we need to know which are the component master node has, and master node has these components and what is the function of these component. And it's very important topic, by the way, guys. Okay, so you have to understand this very well. So guys, master node have 4 important component. One of the component we call it API server. Okay, now what is API server? Let's read it, some of this stuff here. So Kubernetes API server, which is the first component of master node. Now when I read it, it says front end to the control plane. That means it's a front end to the control plane, exposed with API RESTful APIs. That means this can be accessible using the RESTful API. And when you want to send some instruction to API server, it consumes JSON format only. It consumes JSON format. Okay, so that's API server. Now what is API server, guys? Divide this API server into 2 part. In your memory, in your mind, divide into 2 part. API server. So API means, you know that, correct? API will give you one functionality which you can do the CRUD on it, right? Create that functionality through that API, read that, delete that, or update that. You do the CRUD for the API. But here I'm not saying it's an API, it's an API server. That means the component which I'm talking about right now, it has collections of API. That's the reason we call it API server. And it's a front end to the control plane. Front end means if you want to talk to the cluster, I repeat, if you want to talk to the cluster, you need to talk to API server. An API server probably you want to talk to, but API server is not having one API. It is having so many features, so many APIs in it. That's the reason we call it API server. It's a first and foremost component of master node. Okay, it's a front end to the control plane. Okay, so this is the API server. Now, second component, we have a cluster store. Now, what is a cluster store? Now, guys, if you look at this here, if you read it, it says states persistent storage cluster. So see, everything is in master control every cluster, everything of the cluster. So this has to be some storage where they will store all of their meta information. What meta information? The state of the cluster and configuration of the cluster. So where it can store. So actually in the master node, everything is being stored in the cluster store. There's one component of it in the master node. Now, question is, what is this cluster store is powered by? Is it MySQL? It is a Postgres? It is a MongoDB? What exactly this is? No, it is a etcd. That means this cluster store, this application is powered by etcd. Now, what is etcd? It's one of the distributed, consistent, watchable tools to store the data in a form of keys and values. Okay, etc is one of the open source product, freely available. You can check it out. So now anything in Kubernetes, whatever they want to store, they store in the etcd. You can call it etcd component, or you can call it a cluster store. It is being used for the storing all the data, all the state and the configuration of the cluster. Okay, in another way, if I say, if you have the data in a cluster store, if you have data stored in the etcd, that means that data you can find in the cluster. And if you do not have that data in that cluster store, that means that is not exist. I repeat, that is not exist in the cluster. That's the reason we call it the source of truth for the cluster. It's like your brain. So you have to have a backup plan for it. So second component is your cluster store, which is meant for the storing the data for the persistency. It store the state cluster store and configuration file powered by etcd, and etcd is a distributed, consistent and watchable. Make sense? This is your storage in your Kubernetes cluster. Is that clear, guys, for everyone? Guys, is that clear?
Yes.
Yeah. Now, guys, third component in the master node, we have a controller manager. I repeat, in the image you can see controller, but in the heading you can see controller manager. So actually it's a controller manager. So what is a controller manager? What is a controller manager? So guys, just break this down. Controller. So controller means it's one of the thing which is controlling something. Something is being controlled by controller. But another keyword which you see, manager. So if I see it in a different way, controller means to control something, and manager means this component manages multiple controller. That means in a simple way, controller manager controller manager component manages multiple controller, and each controller controls something. What something? So control node, control endpoint, control namespace, control everything, whatever they want to control, and keep talking to API server. Okay, so guys, here any changes which you want to do in the cluster, whether that is there or not, that will be monitored by, that will be controlled by controller manager. Again, I repeat, controller manager has a multiple controller. Each controller will control one thing, and that too in a loop. This is a never ending loop. For example, node controller. This controller will keep checking, this node is attached to my cluster, this node is attached to my cluster, this node is attached to my cluster. This will keep on running in a loop. The moment controller manager, the particular controller like a node controller will report saying that this node is not responding, no problem. Kubernetes will not allocate any resources to that node. To have an entire integrity maintained for the cluster, controller manager is important, because controller managers only report to the API server about the status of their desired things. Are you understanding it, guys? Controller manager, all of you? Yeah. So guys, controller managers always run in the loop. Remember, controller manager is one component, but controller managers has a multiple controller, and each controller again controls something. Okay, so mindful about this. And then there's last component which we have is scheduler. What is a scheduler? So guys, here what happens, scheduler is one of the component in the master node which is watching all the time to API server. But why? Because API server is the only front end which everyone interact with. If you look at the arrow of the images, see API server, cluster stored, controller manager, API server, scheduler, API server. So everyone talk to API server. In fact, you also talk to API server. Everyone within an internal communication and outside of which also everyone talk to API server. So here scheduler also watches the API server, but for what? For the new pod allocation. Work, pod means work. Now what is a pod? We have not discussed, but at least I got to know is like a pod you can see in the node, in the worker node, and the pod have a container, may have a multiple container. In each node you have may have a multiple pod. What is a pod? We don't know, but still some of the stuff we got idea from the previous discussion. So now what is a kube scheduler? So basically this guy is always watching API server. For what? For getting a request for creating a new pod. So that means if you want to create a pod, who will, no, it's a wrong line actually. If you want to create a pod, then someone has to request. So who will request? API server. But scheduler will not create a pod. Mind it here. Scheduler will not create a pod. What scheduler will do? Scheduler will take that request and assign that work to the node. Yes, assignment is a scheduler. It's like a broker sort of it between the API server and node. So see, scheduler keep watching API server for the new nodes and assign work. Work means pod to the nodes, and it can be influenced with many things. Scheduler can be influenced. Something like, okay, assign the pod creation work to only node which has a multiple CPU, which has certain CPU, certain RAM, certain storage, certain label, certain this, certain that, those kind of things. You can do that. That is called anti-affinity, affinity constraint and resources. So you can influence scheduler. Scheduler is a way to assign the work to the node by taking the request from the API server. Okay, so guys, these are the 4 component we have in the Kubernetes master node, and together we call it the control plane or or aka master. So now let's do little bit of visualization, of 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 something like this. Let's do this face, or not face, I want not Facebook, face. See here, let's say, understand that. So this is a
To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
if you look at this this image, look at this very carefully, you know that this is the something like a control entire body, right? So entire body you can assume as a cluster and this as a master node. Okay, so now in this case, when I look at this face, then who which component can be your API server? Any idea which component of your face considered to be your control plane, a master which control the entire body? So out of which can be API server? Any idea? We have so many component here, which can be API server?
Mouth
API server receiving request,
or receiving request here. Yes.
right? So these are 1 year and you have a 2 year. Let's say 1 year is not working, no problem. You have a HA, high availability, correct? HA 2, correct? So here you get a request from outside. Now where do you store? Who's your cluster store? etcd. Who's your etcd? Brain, right? Correct, no? Brain. Now controller manager. Who's your controller manager in this phase? Correct. You have a two controller manager, two controller, this together is a controller manager. Now this guy see everything and respond back and store again. This guy will say go ahead and store this information in the etcd, because everything gets stored in the etcd. And now who's a scheduler who will say who's scheduler who can assign the work to you after listening, storing, analyzing, and then schedule? Scheduler mouth is your scheduler, correct? Right?
Yes. Yes.
So it's like that. So this architecture is beautifully designed, and this is called master component. Okay, so yes, master component, we also call it the control plane components. It has a 4 important components: API server, cluster store, scheduler, and controller manager. So API server is central, simple, RESTful API, and it updates the etcd. Cluster store is your persistent storage. It in store the data in a key and value format powered by etcd, and you can watch it from the any distributed environment. Scheduler watches the API server, it schedule the pod, it has a resources constraint and stuff like that. Controller manager, which has a controller which always runs in the loop. It helps you to manage your desire state. Now what is a desire state? That means I need a 10 pod. So whether 10 pod is there or not, someone needs to update the node is attached to or not, all this stuff. Okay, and you can watch it, update the API server and a replica set. So what is the replica sets? I'll not discuss right now, but we will discuss little bit later. So guys, now we have understood the master node very well. Now if you look at this, the little bit of broader picture, here you see master node have 4 component. There's a node, worker node, and 2 worker node you have here, and each worker node you have a pod, and pod you have a container. And if you look at this, scheduler schedule the work to the node, you see that based upon the instruction from API server. But who control the API server? You see that the bottom section of the image, you have your laptop. That's, we call it workstation. You can call your laptop as a workstation, but in your workstation, in your laptop, what you have? kubectl. Look at this, kubectl. There's one utility, there's one tool. So in this case, if you want to talk to API server, what you need? kubectl. Where? In your laptop. So you can send the instruction to API server. But how do you send an instruction? It has to be in a JSON format. That's your package, that's your deployment package. So whatever you want to create in a cluster, when I say whatever you want to create in a cluster, that means a worker node, then you do one thing, you send to the API server. API server will store in the cluster store. Controller manager will say these resources are not there. API server will say scheduler, go ahead and create these resources. Scheduler will assign. Remember, scheduler will schedule the work. It's a supervisor, it will not do any work. Scheduler will assign the work to the node, and now we need to know. Now next question is, we need to know what we have in the node, what we have in the worker, so pod and container can be created. Are you understanding it? My question is very simple. What we have in the worker node, what we have in the node, so based upon the request from the scheduler, the pod and container would be created. Make sense? Are you getting it? Hello?
Can you please repeat it again, sir?
Yeah. So now guys, let's understand the worker node. So we can call it worker node, worker, the Kubernetes worker, or you can call it a nodes, or you can call it a minions, anything. So guys, if you have watched the Minions movie, the story of worker node is something similar to it. And let's say if you don't remember the Minions movie, then let me tell you here in a short. Minions is a kind of species who's not happy, who's very sad, right? So they need a master. So they need a master, and without a master, the purpose of their life is nothing. So same case with the worker node also. Worker node without a master node, their purpose is nothing to be in a cluster. They are sad. So what happens? Minions look for the masters, request the masters to become a slave, become a minion, and then they serve the master based upon the whatever the request master has it. They serve the master. So same thing, Kubernetes requests the masters node to become a slave, and once the master node approves that okay, you're my slave, then after that one time onwards, scheduler will assign the work to the worker, and then worker will do the work and then send the status back to the master. That is how whole cluster works. Okay, so we can call it a nodes or a minions or the Kubernetes worker. So Kubernetes worker has three important component. What is that? Look at this. First component is Cubelet. Remember here, you might get confused here. I said in workstation you have a kubectl. Don't get confused. Kubelet versus kubectl. Okay, so I'm saying in your workstation, you have a kubectl, but what I'm saying in the worker node, you have Cubelet. Mind it here. So now the question is, what is the Cubelet? So guys, Cubelet is one of the tool which you can find in the each worker, each node. Yes. So you will find in the each node, but what is the work of it? So basically guys, this Cubelet is your basically agent which has to be run in the each worker, so it can get a request from the scheduler, from the master node. Okay, so Cubelet is a main Kubernetes agent which has to be running all the time, and which has to be reporting to API server about their availability. Okay, this itself, the Kubelet itself, helps you to register a node with a cluster. Remember, minions look for the masters. Kubelet is your minion. Kubelet look for the master and request to become a slave for the master, to the master. So here Kubelet is your minion. Kubelet register a node with a cluster. Kubelet minions keep bugging their masters. In the movie, you remember. So Kubelet also keep watching API server all the time. And if some Kubelet has received some request from scheduler, mind it, I said scheduler in a master node, then Kubelet only instantiate a pod. I repeat, who can instantiate a pod? Kubelet. Who can create a container, guys? Who can create a container? Anyone? Who can create a container?
Controller.
No, container. I said container. Docker, right?
Yes.
Docker create a container, guys. Docker engine can create a container. So here I am stating who can instantiate, who can create a pods. Kubelet. Okay, and once the pod is created, a report back to the master, and Kubelet, which is the main Kubernetes agent, on each node it runs on 10255 port number. Okay, that means if you want to access the kubelet, that's a port number. Very simple. So this is the one component which you can find in the each worker, and because of that the node is added to the cluster. If it's not running and it has no approval, it has not registered with the cluster, then that's not a part of the cluster. That node, that worker, that VM is not a part of the cluster. So what is the second important component? So I think this component, you know it very well. Remember, pod is created by kubelet, but pod has what, guys? Pod has what? Can you tell me?
Container.
Container. But container is created by what? Container engine.
Kubelet.
Yeah, Docker. Container cannot be created by kubelet. Mind it. I repeat, container. Pod is instantiated. Pod is created by kubelet. Container is created by Docker. Okay. So second component is your container engine, which is can be Docker or Rocket. The beauty of the Kubernetes is here you can change the container engine. It can be Docker, Rocket, Cryo, and many other Factory, and so many other container engines are there. Okay, so Docker is one of the popular one. So what is the work of Docker? You know that very well. By I assume you know that. If you have not, if you have no idea about the Docker, that's the prerequisite. Please go through my playlist and then watch those videos and get a knowledge on that. Okay, so what is the job of the Docker? You know that pulling the images from the registry and starting the container, stopping the container, and all stuff like that. That's the second component. That means what I'm trying to say, each node of the cluster, you must have container engine, which can be Docker, Rocket, or many other options are also available. Okay, so now third component. Now guys, third component which you can find in the each worker node is called Kubernetes Proxy, Kube Proxy. So what is the job of Kube Proxy? There's the third component. So what is the job of the Kube Proxy? Guys, here Kube Proxy basically helps you to manage your networking. Yes, networking. This I'm discussing at the high level right now. I'm not diving into it because networking we have a 2 to 3 sessions in a dedicated way. Kubernetes networking, I'll discuss about that. But here at a high level, this one of the component which you can find in the each worker node, each node of the cluster, and this will help you to manage the networking in the Kubernetes. But for what? So remember, where do you have an application running? In the container. Where is a container? Inside a pod. So guys, Kube Proxy helps you to assign an IP address to the pod. I repeat, I said pod. That means in the Kubernetes container do not get IP address. I repeat, in a Kubernetes container do not get IP address. Who gets the IP address? Pod. That means if you have a pod and in that pod you have a 2 to 3 containers, all the containers can be accessed by the pod IP address. Yes. Okay.
So container will be accessing by the port numbers.
Pod IP address. Yes.
Pod IP address, but containers, if you wanted to reach to the containers.
That's what. If you want to access the container which is inside a pod, then you have to access the pod IP address.
Suppose in a pod we have more than one container. Let us take like 2 or 3, the count is. In that case,
I'll tell you in simple way. You have your laptop. Are you in front of your laptop? Of course you are, right?
yes.
Right? You have a laptop. Are you running Tomcat? Are you running Apache? Are you running MySQL? 3 application you are running. If I want to access all 3 application, would I need a 3 IP address or only one IP address with a different port? Tell me.
One IP address, different port.
Same situation. You
Okay,
have a 3 containers.
Okay.
Yeah. You have 3 containers inside a pod. Yeah. So port number will change for each container. Correct?
So we can reach to the containers by using the pod IP address along with the container port number.
Right. Yeah, you got it. Remember, if you go through my Docker videos, I have stated multiple times, your container is nothing but a process. Your Tomcat is a process, MySQL is a process, Apache is a process, anything you run is a process, but container is a user process with applications running. So just go through that, you will understand more about it. Okay, so yes, if you want to access, so who is empowering the IP address of the pod? Kubeproxy. Because of Kubeproxy, you get Kubernetes networking, and this component you can find in the each node of your cluster. I repeat, each node of your cluster. And basically this Kubeproxy only helps you to load balance the pods through the service. Now load balance a pod, that's okay, but what is a service? I will hold these questions for a little bit of time till we get into the topics. Yes, Kubeproxy is your networking services. So what is a proxy here? Guys, again, if you're thinking about proxy is something, some sort of Kubeproxy, some sort of application, it's just a proxy between the two things. So if you look at this image here, you have Alice and Bob. Alice wants to send some message to Bob, so he will send to the proxy, and proxy will send that to Bob. Same thing, Bob wants to send something to Alice, then Bob will send to proxy, and proxy will divert that information to Alice, so they cannot talk to directly. So proxy is a one way to travel between the two networks. How it works and all in a detail we'll discuss in the networking session. Okay, why we need this Kubernetes proxy? This three reason you have to hard code in your mind very well. Why do we need a Kubeproxy? It's very simple reason. All pods, mind it here, just visualize this in your mind. Okay, you have no one node, you may have a 10 node, 10 worker nodes, and each node you have a more than 5, 10, 20 pods running. So what is requirement here? Here, let's say Apache pod is running in each node of the cluster, 2 pod of Apache is running in each node of the cluster. So, but you don't want to access all the pods. At a request time, you want to access one pod at a time of Apache, but you have a 10 pod. Each node you have a 2 pods. So why do we need Kubeproxy? Simple answer. All pods can communicate with each other on all nodes. All nodes can communicate with all pods, and no NAT is allowed. This is your Kubernetes networking requirement, specification of networking in Kubernetes. And Kubeproxy will help you to address that. That means each pod will have a single IP address, so each pod can talk to each other across the node, and all node in the cluster also can talk to any pod because of Kubeproxy. So this is your requirement, and because of that you have a Kubeproxy. Again, we'll get into the networking session, we'll discuss more about it. So in a simple way, in a sum up way, what is a Kubeproxy? So Kubeproxy, the Kubernetes network proxy, runs on each node. This reflects services as a defined in the Kubernetes API on each node. Can do simple TCP, UDP, SCTP stream forwarding, and can do round robin TCP, simple also, and round robin, both you can get it done. So can do round robin TCP, UDP, SCTP forwarding as well. So both it can do. Okay, so now you see that here, each node you have a 2 node here, and both the node you have a Kubeproxy, and you see the pod is connected to the bridge. So yep, Kubeproxy helps you to communicate with the pod to pod within a node, pod to pod another node, and with the help of external services as well. So it's very useful component. In short, we can call it a Kubernetes networking services with the help of Kubeproxy, which is the third important component of Kubernetes worker. Okay, so now if you look at this image also here very clearly, you have a one node, Kubernetes node, and Kubernetes node is having Kubeproxy, and you see the Kubeproxy is getting a request from where? API server. API server is where? You know that in the master node. And API server again talk to the IP tables, and IP tables which manages all the IPs of all the pods and services. And here the pod 1 has IP address, pod 2 has certain IP address, pod 3 has certain IP address, where is stored? IP tables. So through this IP tables, Kubeproxy knows that where to transfer that communication. So this is how it works. Okay, look at this image also, very good image. Look at this here. Human talk to API server through kubectl. Remember kubectl, and API server stored the data in the etcd. Again, controller manager keep reporting to API server. Scheduler also keep talking to API server. And here you see kubeproxy also keep talking to API server, and kubelet, which is in the worker node, also keep talking to API server. See the communication arrow. And kubeproxy talk to IP table, which is in the worker node, and kubelet talk to the Docker to create a container, because kubelet instantiate a pod and Docker fill the container inside it. See this whole communication arrow is very important. Are you visualizing this whole thing? Are you visualizing the whole thing?
Sir.
Yeah. So these whole things you have to hard code in your mind. Okay. So in a nutshell, yep. Worker node have three important component: kubelet, container engine, kubeproxy. Kubelet is a main Kubernetes agent. Container engine is a, that can create a container. It can be Docker or Rocket. Kubeproxy, which is a Kubernetes networking services. So altogether, these are the this is the Kubernetes architecture. We have a master node, 4 component, worker node, 3 component. All these components we have discussed, and who is talking to which one we have also discussed and showed you. Okay, so let's sum up this stuff. Nodes, you can find in each node you find the kubelet, kubeproxy, and Docker. What is the job of the kubelet? Monitor the API server for uses, responsible for pods lifecycle, report node and pod state, pod liveliness and props can be implemented. Kubeproxy, which is a network proxy IP tables, implement services, routing traffic to the pod, and helps you through the load balancing. Docker, I think you know that that's a prerequisite. Okay, but guys, there are so many other add-ons also. Add-ons means other components also you will find in the Kubernetes cluster, which I'm not discussing right now, such as DNS, ingress, dashboard, and many more. Okay, so you will find it out, but I'm not discussing right now. So now let's hard code the architecture. Okay, so I will show you 3-4 images, and you can go and see that all this stuff in a consolidated way, and then build your understanding. And if you have a doubt, you can ask me. Look at this image, very good image. Here we can talk to through UI means dashboard. Okay, and kubectl, which is I discussed, to Kubernetes master. But in Kubernetes master, which component we can communicate with? Anyone? Kubernetes master?
Sorry, question please again.
API server.
In the Kubernetes API server, yes, that's correct. So through the UI, like a dashboard, a kubectl, we talk to the API server, and API server, how they interact with each other component, you know that. Now you see here, master component talk to the worker node, and each worker node, very carefully you see the 3 component you have: Docker, kubelet, kubeproxy. Now inside a node you have a pod, multiple pod, and inside a pod you may have a container, multiple containers. So very simple generic figure. Let's complicate a little bit. Okay, look at this here. Again, something similar we have. Same image, but in a different with a different pictures. Okay, see here, UI kubectl talk to control plane talk to the worker node, and different components. Now let's deep dive into that. Look at this here. Now you see here, elaborated format. Developer talk to the developer means you from workstation with the help of UI and kubectl. Talk to the API server. You see the arrow very carefully. API server talk to the etcd. API server can communicate to the controllers. API server talk to the scheduler. Here API server send the communication to the kubelet through scheduler. Scheduler send, actually that request comes from the scheduler, but it passes through API server. Okay, because I repeat, again I'm saying API server is a server containing multiple APIs. So don't think it's just having one functionality. It's just a way to pass the request here and there. Okay, so scheduler pass the request to the kubelet, but through API server only. So API server talk to the kubelet. Okay, and then kubelet, Docker engine, and network proxy. Again you see kubeproxy, and manage the pod. Again you see the right side, it's the same thing. Okay, now you see that very carefully. If thing simple, look at this downside, extreme right. if you want to access the pod, I'm not talking about the you. See, you as a company run the pod, that's your objective. But end user has to access the pod, right? So how would they access? So end user will talk to the IP address and network proxy through that. Load balancers and all will come into the picture a little bit later, but they communicate through to the pod through the network proxy. You see that network proxy, Q proxy, and Q proxy will send the request to the pod. That is how the communication. Let's look at the one more image. Look at it very carefully. See here kubectl talk to API server, controller manager and scheduler talk to API server. Again etcd, again you see the downside somewhere. Again you see the API server talk to the Cubelet. Cubelet talk to the Docker and create a pod and stuff like that. Okay, so different pictures, same visualization. Again look at this here. This is a little bit elaborated format, but towards the end user. Look at the end user hit to the load balancer, and from the load balancer you see where the communication is going to the pod. See that load balancer through the here Q proxy is not there, but you can visualize that Q proxy with the help of the networking services, load balancing networking services. So end user hit the load balancer will send the traffic to the pod through the Q proxy, and the pod will get the traffic, and the pod has a container, and container has application come from the Docker image, or Docker image come from the registry. All these things. Are you able to visualize all this stuff, guys?
Yes, sir. Yes.
Yeah. So guys, this is the simplest one. Okay, so again I would request you all to revisit all this stuff, because you have to hard code all this stuff. So now we have spent good amount of time with the master. We have spent good amount of time with worker also. The last component which is a part of the architecture is what you have in the package, JSON package. Remember deployment package, what you have. So that's the last topic what we have. So now I will cover this stuff in the next session, because again it's a 45 minutes of discussion is pending. So yep, we were discussing about the architecture. As part of the architecture we have a cluster, we have a master, we have a worker, you have multiple master, multiple worker. Master have a 4 component which we have discussed. Worker we have a 3 component which we have discussed. We have a pod, we have a container, and everything it works. And end of the day, end client access that load balancer and then pod, and pod has a container, and that they can access the services inside it, application inside it. Now the question is, most important question is, all this thing will work when you deploy your packages. Deploy your packages means you will say, okay, Kubernetes, give me 10 containers, 10 pod. Kubernetes, give me 10 storage. Kubernetes, give me 10 security related services. So you have to demand, right? For example, AWS. You say, AWS, give me 10 instance. Or you say, AWS, give me 10 EBS storage. AWS, create a VPC. AWS, create a high availability, HA, auto scaling group. All these things you ask for it, right? Same way, you have to ask API server of all the features which is supported by Kubernetes. But the question is, how do you ask? That's important. You have to express all this desire in a JSON file. And in the next session, I'll teach you how to express your desire, because until you won't ask, you won't get it by the Kubernetes. So you have to ask, you have to learn to ask, right? So in the next session, I'll teach you how to express what you want, that's called what is your desire, and how to declare your desire. Okay, any questions so far, guys?
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 3D99 plan, and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.